Today we're gonna talk about binomial theorem and its extended formula. Um, Most of you guys might learn this binomial theorem before, and it is very basic for the positive integer n. And for example, like when x plus 2 of power 3, we can split it by the first term is 3, 0, and x power of 3 times 2 power of 0 plus 3, 1 times x power of 2 times 2 power 1, and so on. So I wrote every terms of this expansion. So it is easy to calculate that is x power 3 plus 3 times x squared times 2. So this is 6 times x squared times 3 times x times 2 squared is 4, so is 12 times x, and plus the last term is 8, right? So we can easily get this equation. And how about the Newton generalized binomial theorem? It is a extended theorem that's that is we can got from basic binomial theorem, right? For its term is when x plus y of power n. The situation is when n is not ever a positive integer. It's not ever positive integer. It could be like a -1 or 1/2, or even complex number I. So here's the equation: x plus y of power n. Ever since n is not positive integer, is sigma k equals 0 to the infinity, and a combinatorics number in R. From times x power n minus k times y of power k. This is the formula. And I think most of you guys might want to learn how to prove this formula, right? Because this is different from this is different from the first one we mentioned, because this is it gets a sum from 0 to infinity, but this one is only get from 0 to n, right? And I think you also want to know if n is like -1, how can we solve it? If n is -1 and maybe k is 2, and how do we solve this one? We're gonna talk about. Firstly, we're gonna prove this, right? For the proof process, first we should know the Taylor series. For the Taylor series, is that if there is a 1 plus maybe 1 plus z of power n, the Taylor series is that it can easily explicit by this equation. And for the Taylor series, we can easily get the transformation of this binomial equations, and we can set a functions f z equals 1 plus z of power n. So if we take the derivative of this function, maybe we take the first derivative, right? We can get n times 1 plus n of power n minus 1, right? So if we take the kth derivative of the function fz, we can get n times n minus 1 times n minus 2 times n minus 3 blah 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 until n plus k n minus k plus 1, right? And there we have a 1 plus z. One plus z of n of power n minus k, right? And when z equals 0, we have n times n minus 1 times n minus 2 times n minus 3 until n minus k plus 1. And therefore, there is 1 of power n minus k, and there's just 1. So 1 times anything is anything. So just simplify this equation, right? So we get this we get this equation from, we take the k times the derivative of function fz. So we can simplify the equation by there is n times n minus 1 until n minus k plus 1 over k times k minus 1 until 1, right? So so we get this equation, and we can write this part as a combinatorical number for n. We can write it as nck, or like this way. I better write it in this way. So it's equal when k equals 0, and this is to infinity, to find the sum So so this is times c and k, and then just times k z of power k. And our aim is to find what will be if x plus y of power n. So we can set the z to x over y. So if z is x over y, right, we can get it by times just take this off, take 1 over y out of equations. So we can find n when x plus 1 of power n. So if we want to find x plus 1 of power n, we can just extract the x or extract the y out of equation. But the one thing you should remember is that there is a prescription that x should smaller, x should bigger or equal to the absolute value of y. So the absolute value of x should bigger or equals to the absolute value of y, because we need the Taylor series. The series should get convergent. If so we divided by x of the equations, and we put x out of the equation, right? So we have y over x of power n. So in this way, y over x should smaller than 1 or equals 1 to make this series to be convergent, so we can get the final value of the equation. So in this way, x have to be greater than y. Maybe some of you might ask, how about when like x is smaller than y? It is easy because we can transfer this equation to 3 plus 2. There's no difference. Okay, so so we have sigma from k equals 0 to infinity, and we have y over x of power n. Of power k. Yes. In that way we have we can simplify this equation by let's those two x combine together. So we have sigma k equals 0 to infinity, and c n k times y of power k times x of power n plus n minus k. Yes. So we get the final equation. So this is the equation that we want. The power n power of a plus y equals to sigma from k equals 0 to infinity of c n k times y of power k times s power n plus k. So that's the final equation. First thing is you need to know Taylor series, right? And second thing is you should know how to take the derivatives of a function. You should set the functions, right? You should set the functions, and you should let the z equals 0 to find the factor of the functions. So then after that you should guess maybe z equals to x over y, and the fifth step is you should know the prescription of the equation. That's the absolute value of x should greater or equals to the absolute value of y. This is subject to the equation. And so this is the